On the afternoon of December 7, 2016, a commercial flight prepared to depart from the mountainous, isolated valley of Chitral, Pakistan. It was a completely standard, routine route. In the cockpit sat Captain Saleh Janjua. He had over 12,000 hours of flight experience and was an official instructor for this specific aircraft type. He knew the plane intimately. The twin-engine ATR-42 had been declared technically fit by ground crews. Carrying 47 passengers, it lifted off the runway without a hitch and progressed through its initial climb past 13,000 feet. The weather was perfectly clear, the crew was elite, and the instruments read completely normal. There was zero indication in the pre-flight checks that this aircraft was harboring a microscopic, fatal flaw. 32 minutes into the journey, a warning light illuminated in the cockpit as the left engine's power dropped to 0%. When an engine dies, pilots initiate a standard procedure called feathering. They angle the dead propeller blades straight into the oncoming wind, allowing them to slice cleanly through the air without creating drag, letting the plane safely fly on its remaining engine. Captain Janjua initiated the feathering sequence twice. The aircraft ignored his inputs completely. Instead of slicing through the wind, the dead blades caught the air flat, forcing the unpowered propeller to spin 120% faster than its normal speed. Pilots can usually compensate for a dead engine, but this runaway propeller turned the left wing into a massive, unyielding wall of aerodynamic resistance. In aviation, massive drag on one side acts like an anchor. The extreme wind resistance began dragging the plane's nose hard to the left. The captain fought back. He locked the steering completely to the right to counter the leftward pull, maxing out power on the right engine. Then an abrupt shift occurred. The rogue left propeller momentarily snapped back to normal, removing the massive drag. The invisible anchor was gone, but the steering was still cranked entirely to the right. Without the counter resistance, the aircraft violently snapped into a 90-degree right wing drop, plummeting over 8,000 feet in a matter of seconds. The crew managed to briefly level the plane after that plunge, but to understand how the aircraft was eventually ripped from the sky, we must peer directly inside the broken engine. To dive deeper into the hidden mechanics of aviation, hit the subscribe button below. Long before Flight 661 took off, a microscopic fracture had formed deep within the metal of a single blade on the left propeller. Under the extreme aerodynamic stress of cruising speed, that tiny flaw threw the entire rotating blade out of balance. This physical imbalance sent severe, tearing vibrations straight through the heavy engine casing. The violent shaking shattered an internal seal, releasing sharp metal shards directly into the engine's oil system. The circulating oil carried those metallic shards straight into the overspeed governor. The metal pieces physically wedged into the gears, jamming the unit completely. The captain was pushing the correct buttons in the cockpit, but the system executing those commands had physically destroyed itself from the inside out. Back in the air, the massive drag returned, bleeding the aircraft of its remaining momentum. The speed dropped below the minimum required for the wings to generate lift. All steering inputs became mathematically useless. The plane fell directly into the rocky hills of Havelian, claiming the lives of all 47 people on board. In the immediate aftermath, aviation authorities and early reports pointed the finger squarely at the cockpit. They suggested the highly experienced Captain Janjua had simply made a fatal error. When an aircraft falls, the easiest instinct is to blame the human holding the steering column. But focusing on crew error often masks the deep structural failures hidden away in an airline's operational protocols. Independent investigators from France ultimately found the truth. The fatal fracture in the left propeller was a pre-existing condition, a crack that the airline's ground maintenance team had ignored during routine inspections. This discovery forced the Civil Aviation Authority to ground the entire national fleet of ATR aircraft. Every single plane had to undergo rigorous emergency reinspection before leaving the tarmac. Aviation safety hinges on the uncompromising diligence of ground maintenance, where a single microscopic oversight becomes a death sentence for those in the air.